Well, this is a second method for this integral. I'm using three videos for to do three methods for that integral. Okay, this is the second method. And the other two methods, now the linkage is below, you can see it. Now the second method uses substitution. Let x be 1 minus u over 1 plus u. So dx will be equal to, use a quotient rule, and this derivative times this one is a negative 1 plus u minus this derivative times this one is a 1 minus u du. Right? So dx is equal to 1 plus u squared, and this ends up with negative 2 du. Right? Yeah. Okay. Okay, so my integral becomes the 1 plus 1 minus u, 1 plus u squared. Now log 1 minus 1 minus u1 over this one. And then times this one, this is negative 2 du, and 1 plus u squared. Then the boundary has been changed. When x equal to 1, that's equal to 0. When x equal to 0, it's equal to 1. Okay. All right. I use this negative to switch the order. 0 to 1. This is equal to x u plus 1 x squared. And this is 2 left. Log 1 plus u. 1 plus u, 1 minus u is equal to log 2. Yeah, du. Very good. Then this one equal to this, speed not jumping. This one equal to, this will be 2, 1 plus u squared. Okay. This will be 2 times log 2u minus log 1 minus u plus u. So 2 to cancel out, becomes a separate 3 integrals. This first one is log 2. Yeah, log 2 over 1 plus u squared du. That's the first integral. Second integral, log u, 1 plus u squared du. And the third integral is minus 0 to 1 log 1 plus u, 1 plus u squared du. Okay. This one is easy. This one is a log 2 times arctangent u from 0 to 1. I call this one as J1, discussed later and separately. This is J2. So this is quarter pi, so it becomes 8. This is log 1 is a quarter pi. So quarter pi log 2 plus J1 minus J2. Okay. Now let me discuss J1, which is this. Log u 1 plus u squared u. I just expand 1 over u squared as a power series. This is equal to integral log u and the sigma from 0 to infinity, negative 1 to the n, u to 2n, and du. Yeah, it's a power series. Now, since this series is convergent in this interval, therefore I can switch the order of the boundary, the operators. So this is 0 to n infinity, and minus 1 to the n, right? The integral about integral u to n. Right? Well, this one is okay. To the n. Now I'm using by parts. Log u, log u times u this. Okay. All right, so this is log u. This is d u at 2n plus 1 over 2n plus 1. Right? Yeah, that one's is u to the 2n du. Now, then I can use by parts u dv. Right? So this is equal to n equals 0, infinity. Take this out. And this is by parts u dv. Right? This is v. This is u. And from 0 to 1 minus v du. V is this. Du is 1 over u. Yeah. This is 0 to infinity. Now for this, when u equals 0, 1, no problem. It's a 0. When u equals 0, this is infinity, negative infinity. This is 0. But this one goes to 0 faster, much faster than this one goes to infinity. Or use L'Hopital's rule. Or one way or the other, we can, this is n to n plus 1. This is 0. One way or the other, this is 0. Then this is a 0 u to n du. So this one is a sigma n equals 0. Infinity, I'm sorry. Minus this one is negative. This is u to n plus 1 over 2n plus 1 from 0 to 1. Right? So it's end up with sigma from 0 to infinity. Okay. Yeah. 2n plus 1. I'm missing that one. So 2n plus 1 square. Right? When u equal to 1 is 1. When u equal to 0 is 0. Negative. N. Yeah. Okay. Sorry for the mess up. This is a Catalan constant, so this is negative G1. Okay, good. So my J1 is a negative G. Now then J2. J2. This is J2, right? This is J2. 0 to 1. Natural log 1 plus U. 1 plus U squared du. Okay, this is my J2. And I'm using substitution. I let U be tangent theta. So this one equal to 1 plus tangent theta. This will be 1 plus tangent square. Du will be secant square. And when U 0, theta 0, when equal to 1 is a quarter pi. Yeah. So this is cancel with that one. So 0 to a quarter pi log of 1 plus tangent theta d theta. Okay, then starts another substitution. Let theta is equal to 1 quarter minus t. So this log 1 plus tangent theta is equal to tangent quarter minus tangent is 1 minus tangent t and 1 plus tangent t. Right? Yeah, and then negative d theta dt. And this is 0, this is quarter pi, this is 0. So this one is equal to, I'll use the negative to switch the boundary, so 0 to quarter pi, and not log 1 plus tangent t, and this will be 2, right? Yeah, dt. Yeah, so this is equal to log 2 dt minus integral log 1 plus tangent t dt. Well, this is J2. This is exactly J2. J2 this, yeah. This one is J2. It's equal to that one. So J2 is equal to twice. So 1/2 of that. Right? Log 2 over. Yeah, so this is a quarter, 1/2, quarter point log 2. So J2 is equal to pi over 8 log 2. Okay. What? Okay. We have this, right? Yeah. I is equal to quarter pi. No, quarter pi, yes. Quarter pi log 2 plus J1 minus J2. That's what we had before. Now, this is equal to quarter pi log 2 plus J1. J1 is a negative G. Yeah. Plus minus J2. So this one is with the eighth power log 2 minus G. Okay, that is the result of integral by method 2. Now these are very good methods for the integral. Okay. Now the other two methods I showed, the link is below. I hope you can go see it, particularly method 3. Method 3 is fantastic. Thank you.